Welcome back again, class. Thank you for joining me for our second day of 5-6, so we can wrap up this fundamental theorem of algebra. So today we're basically going to be reviewing that same concept that we were working on yesterday. Okay, we're going to be applying the synthetic division to find all the zeros of functions. So to start, the fundamental theorem of algebra says we know we're looking for 4 roots because this is a 4th degree, a quartic polynomial. Rational root theorem. Well, for that, I'm looking at the 18. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18, and the factors of 1, which are just plus or minus 1. So far you can kind of see most of the examples we've done, when you end up dividing those, you end up just re-getting the list. If the leading coefficient is 1, you basically just reconstruct the list of the factors of the constant. So now what we're going to do, we're going to graph this so we can find which ones of these possible roots are true roots. So I'm going to call up my calculator and I'm going to graph this beast. So x to the 4 plus x cubed minus 7x squared minus 9x minus 18. So I'm going to graph this and see where my real zeros are. All right, it looks like I've got one at -3 and one at +3. So I'm going to use that information. I'm going to use it so I can use synthetic division to wean this down to a quadratic. So I'm going to start with that -3. So 1x to the 4 plus 1x cubed minus 7x squared minus 9x minus 18. Pull down the first number, multiply by the -3. Add, 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 and it is a true root. So I'm going to put -3 on my list of true roots. And then I'm going to show that this is my remainder, my constant, my x squared, my x cubed. So I'm going to show the polynomial that I'm getting. So there's my linear factor, where -3 is a 0. And now I'm going to write what I have left, okay? Because now I'm going to use synthetic division on that piece right there. Now, looking at the graph, we also said that 3 is a root of this. So I'm going to take that new polynomial, 1x cubed minus 2x squared minus 1x minus 6, and I'm going to use synthetic division on this now. Pull down the 1, multiply by 3. Now I can add, multiply by 3. Add, multiply by 3. Add, and once again, it is a true root. So I'm going to add 3 to my list of roots. So now I've broken down this piece to add another linear factor, x minus 3, and now my remainder is 0, constant of 2, x of 1, x squared of 1. All right, so this is what I have left, okay? I have a quadratic. Now, unfortunately, that quadratic does not factor. I will tell you that right away. So this one you will not be able to factor. You can also not solve it by square rooting because you have an x squared and an x. So that means for this one, we actually have to default to quadratic formula. So I'm going to take this. So we have x squared plus x plus 2 equals 0. I'm going to apply the quadratic formula to this. So we have an a of 1, b of 1, and a c of 2. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x equals negative 1 plus or minus, well, 1 squared minus 8 is going to give me square root of negative 7 over 2. Or incorporating the fact we know that this is imaginary, we can have an I there and that. So these represent our third and fourth roots. So we have negative 3, 3, and then negative 1 plus and minus I squared of 7 all over 2. And that represents all four roots of this polynomial. Okay, and now just a little review again. So to name it based on degree, well, this is a fourth degree polynomial, so that means it's quartic. Name based on number of terms, well, I see it has 1, 2, 3, 4, 5 terms, so polynomial of 5 terms. Is end behavior, if you look at the graph, is end behavior, it goes up on both sides, so it's going up to positive infinity, both to the left and to the right. All right, so let's go to our final example. All right, we're only going to do 2 today, just to make sure you are refamiliarized with how to do this process. So we know based on the fundamental theorem of algebra, we're looking for 4 roots. Now, I have negative 6 here, so it gives me plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6 as my factors. Then the 2 there means plus or minus 1, plus or minus 2. So when I divide those, because I can divide by 1, I get all of these back. But now since I can divide by 2, that also gives me 1/2 and 3/2 in the mix. All right, so those are all of my possible rational roots. Now, let's see which ones are true roots. So, let's go into our calculator. Clear out the equation we've got. Let's plug this in. 2x to the 4 minus 3x cubed minus x minus 6. Let's graph this and see. So those are the possible roots. Let's see which ones actually are roots. So I'm seeing negative 1 and 2 as my roots. So let's come back and start our synthetic division. So we said negative 1 is a root. So let's use synthetic division to break it down. 2x to the 4, negative 3x cubed, no x squareds, negative 1x, negative 6. All right, let's bring this down. To bring down the 2, multiply by -1. Add, multiply by -1. Add, multiply by -1. Add, multiply by -1. Finally add, and there we have a remainder of 0, constant of 6, x of 5, x squared of -5, x cubed of 2. So I'm going to put -1 in my list of actual roots. Then I'm going to show what I'm constructing. So I have x plus 1 as a linear factor. Now I have 2x cubed minus 5x squared plus 5x minus 6. That's what I have left. So now I'm going to use synthetic division on that new polynomial using the other root, the root of 2 that I saw in my graph. So, root of 2, so I have 2x cubed, negative 5x squared, 5x, and negative 6. I'm going to pull down the 2, and now multiply by 2. Add, multiply by 2. Add, multiply by 2, and add. And once again, it did turn out to be a real root. So now I'm going to break this down even further because now I've added another piece to my linear term, and now 2x squared minus x plus 3 is a quadratic that I have left. I've now broken it all the way down to a quadratic. And once again, I would tell you right off the bat that this actually does not factor. So what that means is I'm going to have to use the quadratic formula on that last piece to figure out the final 2 roots. So we have 2x squared minus x plus 3 equals 0. I'm going to use the quadratic formula. X equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. So that leaves me with 1 plus or minus the square root. So I have 1 minus 24. So that'll give me a negative 23 inside there, all over 4. And again, to show that we recognize we're dealing with imaginary numbers, I'm going to pull out the I. And now those 2 values right there, those represent my final 2 solutions. So -1, 2, then 1 plus or minus I squared of 23 all over 4. Right, and again, just to wrap this chapter up in a nice little package, to do our review, again, we're dealing with a degree 4 polynomial, so that is a quartic polynomial. It has 4 terms, so it's a polynomial of 4 terms. And then, as it goes off to both sides, both are going up. So both are going to positive infinity. All right, thank you for joining me for this last piece of the notes video. Please come back to class with all this filled out, ready to do some practice work for me.